All right, welcome to our notes today on angles. Let's take a moment and read through this chart. Go ahead and pause the video, give it a read, and then I'll give you a summary here in a second. So an angle is formed with two rays. You can see those two rays here. We got ray AB and ray AC. Those are also just called the sides of an angle. And they meet at what's called the vertex, which is a point. The vertex is a point, and it's where those two rays meet. So you see we can name this angle in three different ways. It's angle 1, and we use that little angle symbol. You could also call it BAC or CAB. So you just have to name the letters that go in the order of that little L shape there. Okay, doesn't matter if you go forwards or backwards, but there's three ways to name that angle there. Okay, so all of that naming there is super important, so it's all there for you. So what are some other ways you can name angle 1? Well, for one, you could just name it angle 1, but we already have that name. So you always want to make sure you have the vertex M in the middle, but it doesn't matter the order. So these would be two names for 1, J, M, K, and the other way around as well. And then, what do you think for angle 2? Same deal. How about K, M, L, and L, M, K? Okay, so as you know from grade school, there are 3, maybe 4 types of angles. One of them is the acute angle, and that's when the angle is between 0 and 90 degrees. Now, degrees is like, it's an amount of turning. So if we turn all the way around, that's 360 degrees. So anything less than a quarter turn is an acute angle. A right angle, which we're going to use this definition of the right angle later, is just that a right angle means that the angle measure is 90 degrees. An obtuse angle is anywhere between 90 and 180. And a straight angle, which we don't really refer to a straight angle a bunch, but you'll see it in some of the definitions. It's just an angle that's 180 degrees. So this is a half turn. If you imagine this ray right there, just pulling a 180 and turning around, that's a straight angle. So we can use protractors to measure angles, and it depends where the first letters are. So FA means we're starting here, and then we're going to the third point there. So that angle looks like it's acute, so 70 would make sense for that measure. Okay. Now if we erase that second ray and instead move it so it's at C, that would be angle FAC. And its measure, by the way, that's what this little M means. That means we're not talking about the angle, we're talking about the size of the angle. And if you look at the measurements, it looks like that angle is at 155 degrees. Okay. FAD is right there at 90 degrees. BAE means we got to change, so we're starting here, and we're going up to E. So in black, that looks like it's a obtuse angle, so we're going to pick the bigger measurement there, 110 degrees. And BAC would be 25 degrees. So protractors help us find those measurements when we aren't sure. But a lot of times in our figures, they'll be labeled angles too. Another big reason, another key piece of info from this class is that congruent angles have equal measure. So again, angles, when you put an M in front of it, it's talking about its size. It's a number. And when you just have the angle, it's an object. So the statement would be, if the measures of the angles are the same, then the angles are congruent, or the same shape and size. And vice versa, or conversely, it's also true. So if the angles are congruent, then their measures are the same. It's kind of like the same for segments. So be sure you know the difference between the measure of an angle and the object, the angle itself. Okay. A bit more vocab here too. An interior angle measures from 0 to 180, and a reflex angle measures from 180 to 360. So if I just draw a quick picture here, say this is like a 25-degree angle, that would be an interior angle. But if I'm talking about this angle, which, remember, 360 is a full turn, so if we subtract 25 from that, that would be a reflex angle. We don't refer, so every angle, even this angle right here, it has a measure that's an acute angle, but it also has a measure that's like over 300 degrees. We will almost always be referring to the interior angle. So we won't really ever have angle measurements that are above 180. But that's what it is. That's how you name it. Okay, so the follow-up to the segment addition postulate from the last section is the angle addition postulate. And it's the exact same statement, but it's just for angles. So if B is there in the interior of this wide obtuse angle here, it could be an acute angle, doesn't have to be obtuse. But if B is in the middle there, then this yellow angle, AOB, and if you add it to BOC, their measures, you get the entire angle. So this is really, again, just another way of saying part plus part is the whole. So let's take a look at some examples that practice that. So, so when you see angles like this that are touching, you see that it's asking about ROT and it's giving, or it's asking about the others, but it gives you ROT, it's probably safe to say that you're going to use the angle addition postulate. And that is that this whole angle, ROT right there, it's made up of two smaller angles, ROS and TOS, or SOT, whatever. So then you just plug in. So I'm just going to, ROS, its measure, its size is 4x minus 20. And TOS, its measure is 3x plus 14. So this is 7x. Minus 6. We'll just go through and solve this. I know you guys can figure this out. Let's see. 7 divided by... Getting all the notifications now. This is 21. No, 23. You can trust me. And just like before with the segments, we have to plug this number in so that we can figure out what's what. So 4 times 23 minus 20 will be an answer, and 3 times 23 plus 14 is an answer too. Okay, so what is this? This one's 72 if you do the math. 72 degrees. And this one over here looks like it's 83 degrees. So if you wanted to summarize, you could say this and this. Again, when I'm stating the size of an angle, I need to put that M, because again, the angle as an object is not equal to 72 degrees. The angle as a its measure is 72 degrees. All right, straight angle TQR. So TQR could be split into two different angles, and that's what we're going to do here. So a straight angle is 180 degrees in measure. So our equation should be 180 equals the two angles added together. Because these are actually what's called adjacent angles. We'll talk about this in a second. But when they're touching like this and they share a ray, you can add them up. And that's what the angle addition postulate says. Only when they're touching like this can you do this. And you can. This one's straightforward. So 8x plus 24 is 180. Subtract. And I think we actually get x as a decimal here, but it'll turn out okay. Okay, then they want us to just solve for x, so we can stop there. Okay, so the second part of the notes are the definitions of the angle pairs. So if 1 and 2 are supplementary, so that's the new vocab word, which that's like in the top 3 for this class. We'll use supplementary all the time. They're supplementary if the measure of one of them plus the measure of another is 180 degrees. And you probably have seen that word before in like geometry in 7th and 8th grade. So a picture to this would be like two angles that make a line. Sorry, my handwriting's bad because my iPad's being funny about me resting my hand on it. Those two angles add to 180 because it's a straight angle. It's kind of just like the example we just did. And then complementary angles add to 90. And we use that a lot as well. So if you had a 90-degree angle, which we use that little box for, and if that was broken up into two angles, 1 and 2, if you added those together, it would be 90 degrees. Okay. Vertical angles, also really, really important. We're going to use a theorem about vertical angles as one of our reasons, but the definition of the true definition of vertical angles is a little confusing. It's if their sides or their rays are opposite rays. But I like to just remember like vertical angles are like a cross. So they always make an X. So that's one pair of opposite rays. That's another pair of opposite rays. If the angles kind of share those, so like those two, those are called vertical angles. And it's actually a theorem that vertical angles are congruent. And we'll talk about that in a few weeks, of why that's the case. We'll prove that. And adjacent angles, I already mentioned a little bit, they share a ray. And if that doesn't click, you could just say that they're touching. So that would be like something like this. Like they share this ray. And when angles are touching like that, you can say a number of things. One thing is that if you add the measures of angle 1 and 2 together, you get the whole thing. That's the angle addition postulate. But that's the definition, and those are the pictures. So on this diagram, these are the last two things here. Let's go ahead and find a pair of complementary angles. So the rule is complementary just has to add to 90. They don't have to be adjacent or anything. They just have to add to 90. So I noticed that 62 plus 28 is 90. So maybe if I had AFE and the 28-degree angle, BFC, those are considered complementary because they add to 180. That's the only part of the definition. They just have to add to 180. And same thing here. Supplementary angles, I noticed that 62 plus 118 is 180. So we could use that same angle AFE and the 118-degree angle EFD. And in this case, they are adjacent, which is nice. And you see how they make that, like, together they're separate, but if you consider them, they're separate, but if you consider them together, it makes a straight angle. Not required, but just like this picture here, supplementary angles normally lie on the same line. So, which angle can be paired with AFE, which is this one, to be a vertical angle? Well, you have to, if you want, you can extend the lines like this. Extend those sides of that original angle, and then you can see that angle CFD is the vertical angle because, again, when you think vertical, just think of this picture here or this picture. So you're searching for that angle that's across, not adjacent, it's across. And then it says name an angle adjacent to AFB. So I think you have two choices here. So AFB is here. So this angle here is touching it, and so is this one. So I would just maybe say BFC. Because those angles are kind of like that. They share BF as a ray. And then the very, very last piece of info is just the vocabulary for a linear pair. So a linear pair, we've already kind of talked about it, is two angles that form a straight angle. So, and there's this fact that if you have a linear pair, then the angles on there are supplementary. So like if this, you could imagine this is like 50, and this would have to be 130 because a line is 180 degrees, so it has to add to that. So that is a big reason as well. So whenever they use the vocabulary linear pair in a proof, we often use this to like convert it to like degrees. So rather than talking about linear pair, then we can talk about two angles that add to 180, and that normally progresses us through a proof. So this is our last reason. So I think there's 6 reasons in this note. So there's in these notes. So there's a lot of vocabulary here. So if you have any questions, you can let me know, but now you can try the homework. And yeah, and again, if you were absent, just touch base with me and I can give you a blank copy of this. I can point you in the direction of the notes on Schoology, whatever.